All right, everybody, welcome back. So, in this section, we're going to do objective B, which instead of central tendency, we're going to do the outliers. So the measures of variance, how varied my data was. And you can see where there's really three measures of variance: the range, the variance, and then something called standard deviation. Range is going to be the easiest formula, because it's simply high minus low. Variance and standard deviation we're going to pull off our calculator. And you already saw that range we're going to do on our calculator as well, but you do need to know the formula for range. So just like last time, let's get it into our calculator under the stat menu. So I'm going to hit stat, edit, clear that out. Let's go to one variable stat. All right. So let me get this copied so we can actually work with it. Here's my first page of the one variable stat. And here's my second page. Alrighty. So let's take a look at what we got. So the range here, again, is going to be high minus low. So 15 minus 6, and 15 minus 6, my range is 9. The standard deviation is simply this number right here. So we'll round that off, and we'll say the standard deviation is 2.38. Now, what that measures is how spread out the data is. That's what the whole point of it is, how varied it is. So the range gives me a high minus low, so it kind of tells me the difference between the top and the lowest score. The standard deviation is a measurement that tells me how spread out all of the data values is. So there's a relationship there, but it's not really one-to-one. The bigger the standard deviation, the more spread out the data is. If the standard deviation is very small, that means all of the numbers are very clustered together, which they are here. You see a standard deviation of 2 tells me they're all right around the same value, which they pretty much are. Now, variance is a little different, but it's not anything tough. It's simply the value of the standard deviation squared. So I'm going to type in my standard deviation and square it, and that gives me variance. Variance is also the measure of the spread of the data. And in statistical circles, it's a difference, but for here, we're just going to know it as the square of the standard deviation. And these are really our sets of dispersion, how spread out my data is. And you can see that's what we're going to do, and we're going to do it with the same class limits and frequency that we did before. So this time, again, we're going to change these to averages. And get rid of the limits and just make this one number. Now here, it does become a challenge. Because we are limited to using standard deviation in our calculator, we literally have to enter that in 43 times. So this becomes pretty tedious. When I go to my stat, edit, so 94 goes in 6 times. 103 needs to go in 22 times. And then 112 needs to go in 43 times. And at this point, I'm just going to pause the video. I'll enter all these in. You guys can too, but I'm not going to make you watch me type all this out. So I'll be right back. Okay, so I've entered this in, and I got a standard deviation of 9.06. Now, that could also be a little off too, because I'm entering this in, and there's a little leeway here. If you're off a couple of the 43s, obviously this is going to take a little while to do, so we're not worried about trying to get this exact. Just make sure you do as careful as you can. The variance then would be, 81 or some change, because you would square it. Okay. The last part of this is going to be something called a z-score. And a z-score measures the standard deviation of one individual score. So your personal test score, how does that relate in terms of the class? So a higher z-score would end up being much better, and a lower z-score or negative would mean you're worse than average. So this really measures how much better or worse than average your individual score was. So the formula for z-score, whoops, my smartboard decided to stop working here for a second, so let's go ahead and fix that. And the formula for z-score is the individual value minus the mean divided by the standard deviation. And that's what this one's asking. Okay? So in the first one, oops, I'm sorry. I'm a little bit ahead of myself. Let's hold off on z-score for a second, because I thought I said one student, but this is actually just asking about standard deviation. They ask you in this question, so let's forget that for a second. They want to know which class is more variable in score, and this one, the first class is, because it has a higher standard deviation. That's all this question is asking. Which one has the higher standard deviation? Because the bigger the standard deviation, the more variable the scores are. Okay. The last part of this, we'll get to z-scores later. I got a little bit ahead of myself. The last part of this is, now that I know what standard deviation is and how spread out it is, I can actually find how much of the kids, or how many scores will be between two different values. And here's what this looks like. What we have is that most of the scores are going right on here, right around the mean. That's why right in the middle, these are bigger. Then around the mean, as I get farther and farther away, there's less and less values. So what this is asking us to do is actually putting some values in here. And what it's saying is that the mean is 80, and I want to know how much will be between 60 and 100. So how many scores will be between these two values? Well, it turns out that our calculator will do this as well. It'll actually put a percentage, a chance of how much percent of values are between two numbers here. And what we're going to do is we're going to go to distribution right here, and we want a normal CDF. And what we enter in is the lowest value, the highest value, the mean, and the standard deviation. And it tells us that 16% of the values will be between those two numbers. It gives us the probability. So this is the probability that your test score will be between a 60 and 100. And that's what we're asking on the rest of these. So in this case, find me the probability that it's between a 55 and a 105, with a mean of 80 and a standard deviation of 10. You can see this one, because that, the percentage value between those two values was so large that it's a 99% chance that your score is between there. On number 6, this is the same thing. In fact, we're going to have you skip number 6 because I don't need you to do this part. So, yeah, don't worry about this one. We're just going to do 1 through 5. All right, the last portion of this now is z-score. So I told you it was coming. I was just a little early on it. Z-score measures the individual data value. So it literally measures what your individual score was on this test and how it relates to the rest of your peers. So a very big z-score means you are well above average, and a very small z-score means you are well below average. So for each of these, we're just going to plug in the number itself minus the mean, divide by the standard deviation. The number itself minus the mean, divide by the standard deviation. Like so. And when we enter each of those into the calculator, we're going to end up with 1.5, 2.4, 1.5, negative 1.5. And the z-score simply says, well, this score was above average because it's positive. This score was below average because it was negative. This score of the 100 was right at average because the average was 100. This score was much better than this score because it was bigger, and this was the smallest score because it was smallest. And that's what standard deviation says. Now, why is that good for you all? Well, because it tells you how you did in the class without having to know anybody else's scores. So if I give you that the class average was 100 and standard deviation was 10, you can calculate how your score did compared to everybody else without having to actually swap papers and look. They give you this on SATs when they tell you about the percentiles and things like that. It's the same idea. So on this one, we're actually going to find the standard deviation of each, or the z-score of each. And then the better relative position tells me which number is bigger. So for A, the 43 minus 40 over 3. For B, it'd be 75 minus 72 over 5. And your job would be, let's see what each of those is. So this is a z-score of 1, and this is a z-score of 0.6. So both of these students did above average, but the first one, the kid that scored the 43, actually did better compared to his peers in the class. Okay, our last section here is something called a 5-number summary. And what it is it's a box plot. A 5-number summary is a box plot. And what we're looking for on our box plot is 5 things, hence the 5 numbers. We're looking for the lowest value, the highest value, the median, and then we're looking for something called Q3 and Q1. And what those are, they're the edges of the box, but they're also the medians of the median. So what they do is they say, okay, well, let's just look at this. Q1 is right in the middle there, and Q3 is right in the middle there. So it's the middle of the middle almost. And then your box plot's constructed by just doing that. Well, like everything else, the box plot can be done in our calculator. And we're going to pull it up the exact same way. Oh, hang on 1 second. Sorry about that. Okay, so let's enter in stat edit. Clear this out. Oops. Okay, and actually the only numbers we're going to need are going to be right there. So I'm just going to copy that. And if you look, there's your 5-number summary. The 5 numbers there, low, high, median, and then Q1, Q3. And that actually gives us our box plot. Now, to draw your box plot, you got to be a little careful. This can't just be a box with those numbers on it. You actually have to put those on a number line. So right there's a point, and right there's a point, because the size of the box matters. So if I want 5.5 would be right about there. Here's 7.5. Whoops. It's not 7.5. Here's 7.5. Here's 8.5, and there is 10. And what you do is you make your box that way. It doesn't have to be great, but the size of the box really matters. You can't just put a general box because the scale matters. But other than that, there's your 5-number summary. A stem and leaf, which is our last one, stem, leaf, is a way to organize it when we don't want to write them all out. So no numbers start with 0, so I'm good. The numbers that start with 1 are 19, 18, like so. And then we want to put these in order. So I've got 2 9s, an 8, and a 7. Like so. For the 20s, I've got 21, 24, I've got a lot of these. All right. So that's going to be a little harder to do. So let's just pull those over here. Now let's write them in order. I've got 5 zeros. 1, 2, 3, 4, 5. I've got 3 1s, a 2, a 3, no, 2 4s, and 2 5s. Phew. There we go. And there's no 3, so I'm good to go. And you guys have done stem and leaf, so I'm not going to spend too much time on those. Throw some commas in here, make it look good, but it has to be in order. Oops. And then finally, I'd want you to interpret the 5 number based on the stem and leaf. And I'm not going to enter these in. I think you guys can enter in 45, 54, 57, and find the box plot from that. All right, so there's your section. I've printed out another practice sheet for you, so go ahead and practice that as your notes. And then when we're ready, we'll take a quiz on this, probably at the end of the night. Good luck.